dealing with multi-cloud strategies have been at the forefront of so many different organizations' minds lately. Everyone's trying to figure out how to connect across clouds securely, reduce that complexity, and keep performance predictable. We'll show how you can simplify that setup, make it more consistent, and build a network that's actually ready for the way your business runs today. Let's start at the foundation layer, the network edge layer.
Network Edge is essentially Equinix's platform for running virtual network functions, VNFs. So you run them directly on Equinix managed infrastructure. You can deploy the same devices you'd normally rack and stack, like a Cisco Catalyst 8KV or Palo Alto VM series firewalls, but in minutes instead of weeks. Now, when we say plane A and plane B, we're talking about two completely independent physical planes inside the Equinix Network Edge environment. Each plane has its own compute, storage, power, and network connectivity. So when you deploy a redundant pair of devices, one sits on plane A and the other sits on plane B, that's real physical diversity. It's not just like virtual clustering or something like that. So if plane A ever experiences a fault, plane B continues without disruption. We even include out-of-band management links between them so admins can reach either device securely, even if the primary control plane goes down.
And that's actually a really important distinction because this isn't just two virtual machines running on the same host. You're getting this physical layer separation under the hood. And I like that you actually mentioned familiar vendors because these are like the same routers and firewalls enterprises are already using today and they trust. And they just happen to be deployed virtually in these Equinix metros. So the learning curve should be fairly minimal, right?
Right, exactly. So you can bring your own license or use subscription licensing depending on the vendor. And once deployed, these devices behave like any Cisco or Palo Alto, Fortinet, etc. It works like all those devices you're already familiar with. You get the same CLI, the same APIs, the same monitoring integrations.
And then because it's sitting in these Equinix facilities, they're actually, adjacent to these major cloud on-ramps. And I personally believe that that proximity is what makes the next piece, Equinix Fabric, actually so powerful. Because like from the moment you spin up these routers, they're actually already positioned to connect privately to Azure or Oracle, AWS, Google, the works, right?
Yeah, exactly. And you think of Network Edge as a control layer and Fabric as a transport layer. So the two work hand in hand. Virtual devices give you routing and security. Fabric gives you the private, high performance path between your environments.
Let's dive into that fabric layer just a little bit deeper. I'm seeing here the reference design shows these redundant connections to Azure ExpressRoute and Oracle FastConnect. Why is that private connectivity such a big deal here?
Because it removes the public internet from the equation. With Fabric, you're connecting directly into the cloud provider's edge inside the same facility, reducing hops and no exposure to unpredictable latency or congestion. Each connection is provisioned as a virtual circuit that runs over separate physical paths, again, plane A and plane B, which means the connectivity layer itself is redundant. This can address resiliency needed by cloud providers since an SLA isn't provided by some CSPs for a single virtual circuit. And with Equinix Fabric, you can get redundant circuits and also be assured we have redundant infrastructure for them to go across.
So, is there also a cost saving story here, maybe?
Yeah, so private interconnection typically reduces egress fees because you're using dedicated links rather than routing over the public internet. And with Equinix Fabric, you have dedicated bandwidth for each cloud and service provider you are connecting to, also reducing the bandwidth limitations caused by running VPN over the internet.
Private connectivity isn't just about like speed or security. It's also kind of about control because you now know where your data is going and what path it takes, and you can actually predict that performance, right?
Yeah, correct. And for engineers, the best part is how quickly you can spin this up. Using the portal or APIs, you can create and test new cloud connections in minutes. Some teams even automate it entirely with Terraform or Pulumi so they can scale on demand. And we provide observability data, which can be streamed to Splunk, Datadog, Slack, or Teams, and even set up a data stream to monitoring services that are within the clouds so you can keep an eye on your Equinix services.
Okay, so to sum it up, you've got your routers, your firewalls on dual planes, providing this redundant control and inspection. You've also got Fabric handling redundant private low latency path to each cloud. And together, that's your hybrid multi-cloud backbone, fully software defined, but enterprise grade.
Absolutely. There you go.
Now that we've connected the dots on how private connectivity through Equinix Fabric works, let's take a little bit of a shift and focus on what happens when you're actually inside the cloud. Because connecting to a cloud provider is just really the first step, but routing traffic correctly within that environment is actually an entirely different layer.
Yeah, and that's really important because when you connect into a cloud, services like Azure ExpressRoute or Oracle Cloud FastConnect, you're landing that traffic into the cloud provider's virtual network construct, a VNet in Azure or a VCN in Oracle Cloud. So to make those connections functional, you need specialized routing gateways inside the CSP environment. So these could be services like the Azure Expressway Gateway or Oracle Cloud Dynamic Routing Gateway. These are responsible for exchanging routes and routing traffic flows between your Equinix environment and the cloud resources.
So you're no longer in the public internet. You may need to adjust how your cloud is configured to handle these private paths and segmented traffic.
Yeah, so depending on your setup, you might need additional cloud services to make that routing work as intended. For example, a NAT gateway for outbound traffic or specific security appliances for filtering and inspection. You may also have to redesign how your network is segmented within the cloud to ensure the traffic flows securely between workloads.
And that's where cost can actually come into play too, right? Because once you start adding gateways and NAT functions and segmentation, there may be these like incremental charges from the cloud provider that customers should also be factoring in.
Exactly right. So it's definitely something you want to plan for. Each cloud handles private routing and egress differently, and those associated gateway and service fees can vary. So this is really more for awareness and design planning. You'll need to ensure network engineers understand the cloud native components that are required once you've established those private connections through the fabric.
Okay, great call out because while Equinix enables the private path and the performance, the configuration inside the cloud is fully within the customer's control. So you have to ensure your environment from routing to security to user access aligns with that new architecture.
Yep. So you have to think of it as two halves of the puzzle. Equinix gives you the private interconnection and platform level redundancy, while your team manages how the private connectivity integrates with your existing cloud environment.
All right. So to recap, once your private connectivity is in place, make sure you're accounting for the cloud side routing and network services that complete the path. So, whether that's gateways, NAT, segmentation, or security layers, those are these essential things to getting traffic to flow the way you expect it to. So, to bring it all together, what this reference design really shows us is that hybrid multi cloud networking doesn't have to be complex. But when you combine virtual network functions or virtualized network functions with private connectivity and that multi layer redundancy, you get the kind of flexibility and control that used to take months of planning and deployment.
Yes, so the combination of Network Edge and Equinix Fabric gives you a consistent cloud adjacent foundation for managing your multi cloud and service provider connectivity. You can deploy routers and firewalls in minutes and connect to multiple clouds privately and know that the entire environment is built with physical and logical diversity from the very beginning.
That's what's most powerful here. It's not just this conceptual design, it's something teams can actually even replicate. So, whether you're connecting to two clouds, five, or even extending to a new region, the architecture scales seamlessly and it's actually designed for change.
And because everything is software defined, teams can iterate fast. You can start small, maybe a single pair of routers, and once you've proven the setup, scale it globally without re architecting from scratch.